If you are someone preparing for interviews in AI, there's one topic you can't afford to overlook, and that's RAG, Retrieval Augmented Generation. It's becoming a key focus in interviews nowadays, and in this video, we will cover RAG and dive into how it addresses issues like hallucinations, bias, and knowledge cutoff, giving you a deeper understanding of these AI challenges. And this video is just a small glimpse of what we cover in our live AI/ML program. And if you're eager to learn more about the proven 3-step framework that has helped many like Debashish, Arun, and Roshan land high-paying jobs and certifications, please make sure that you join our free live masterclass. Our experts will walk you through the steps and guide you towards securing your dream job. So don't miss out on this opportunity. Make sure that you register through the link given in the description. So let's get started with the video.
Why do we need RAG? Okay, so let me give a simple idea. Okay, so these LLMs, as just now we discussed, this can do hallucination. They can hallucinate. Okay, so that is one problem. There are several problems. Bias was another problem. Third is knowledge cutoff. Knowledge cutoff. That is another problem. Okay, knowledge cutoff date. So what it means is, without having the capability of searching the internet, if you ask any question which happened, or if you're asking about a question, about an event which just happened yesterday or last week, it will say that I don't know about such an event or something like that, because each of these models would have a knowledge cutoff date. That is the day when these models were trained. So now many of these models, at least the ones which are hosted on their own servers, okay, the good ones, they have the web search capabilities enabled. But if you're taking a model from, let's say, Hugging Face, and you are running it locally, there you don't have the capability of doing a web search. Okay, you have to use the model standalone based on whatever capability it has, based on its training. So we are still into the problem number 3. Okay, so let's discuss about the problem number 3, and that's how we will take the discussion further. Okay, so what is this problem number 3 essentially? It means that if I'm asking about a question of about an event or anything which the model has not seen in its training data, either because of recency issue. Recency issue means, let's say the model was trained in June and this event occurred in July or August. Okay, that is a recency issue, because you are asking about something which has just occurred recently. Or number 2, you are asking about some information which was never in the public domain. So a lot of enterprise data, in fact 90% of the enterprise data was, or rather is, never made public, because these could be quite sensitive data about each of these companies. Okay, their product informations, descriptions, okay, a lot of policies, all sort of closed information is there in almost every organization, which is not available for general use or public use. Even that is not present on their website. Website is just mostly for marketing and basic know-how about what the company is doing. Okay, of course there are websites which do publish white papers and application notes for the purpose of educating, but again a lot of closed source information is held back. So now if you're asking any question which is present in the enterprise documentation, but that enterprise documentation is never made public, so in good faith, 99.99% chances are there that these models would have no knowledge about that data. Although that data is not recent, let's say it's a 5-year-old data, or data, when I say, I'm talking about that particular information. Okay, but that information is not new. Only problem is that information never made it to internet publicly. Okay, so this model can still not answer, right? or it will still hallucinate, give a made up answer. Okay. So the problem that I'm discussing is about the context. Okay. Context not present, or enough context not present to give you the right answer, to give you the for the right answer, let's say. That's the big problem that I'm discussing here. Fine. So what we can do is, one solution to this is using a web search tool. But again, this is not a always feasible solution if you are going with a uh, open source model, number one, because most of the open source model will not be capable of using tools by themselves. So you need to orchestrate some sort of an agent which does the search on model's behalf and then passes that information to the model. We will create an end-to-end application. We'll take open source model which does not have any idea about that event, and then we will create an agent which will do the web search. Output of that web search will be a kind of a web page, not one information, but let's say the top 5 web pages. We'll scrape that, provide that as a context back to the LLM, and then the LLM will try to identify the. Okay, so here still it doesn't solve the problem, because even if you are doing web search, even if you are doing the web search and retrieving the top, let's say 10 results, your results are what? Web pages. So that info that you are specifically looking for, that info is now scattered across 10 web pages. But somehow it is still present. Okay, somehow it is still present. Okay, now those top 10 results are given back to the LLM. Let's say you are giving it back to the LLM, okay, as a context, and from there it is able to generate. Fine. This can solve the not enough problem to some extent. Okay, where web search is giving you top 10 result, and in good faith, this top 10 result contains the information that you are looking for. Fine. But still, there could be scenarios where the web search may not be a feasible option. Okay. For example, think about the enterprise document, okay, which is never present on internet, and that document contains that information, and you are asking the LLM about that information. Fine. So then what is the solution in this case? So this was approach A. The approach B is provide this enterprise document to the LLM as context. Okay. So this is what you typically do on ChatGPT. You upload a PDF and then you can immediately start asking questions on that PDF. That PDF is something which the LLM had never seen, but now it is able to read that PDF, number one, and it knows the contents of those PDF. Okay, and it is able to give you the answer or perform action, whatever you are expecting. Fine. So that information goes as the context to the LLM, and now the LLM tries to find out the actual information from this huge context. What if this document contains, now there could be two scenarios in this, okay, 10 pages versus 1000 pages. Now let's come to two extremes. If this document contains 10 pages, most likely your problem is solved, because it will fit easily in the context window of the LLM. All of the LLMs have a specific context window. For example, it could be 128,000 tokens or 200,000 tokens. These are the most common context windows you will get in most of the LLMs. Okay, so I mentioned tokens. Tokens are like um, words or parts of words. Okay, so most of the LLMs today that you see, for example, GPT models, they are 128,000 tokens as the context window, or 200,000. So for example, your GPT-4o, 200,000 tokens, GPT uh, 5, again, that is also 200,000 tokens. Okay, the previous version, 4o mini and kind of those models, or 4.1 mini, those are 128,000 tokens. Now your Gemini models 2.5 Pro, that has 1 million token limit. That is the only model which has that. Sonnet models, I think, also has 200,000 tokens, but the later one, which is Opus model, okay, that has 1 million token again. So some of the models do have even higher. So DeepSeek model, for example, I think DeepSeek has 1 million token limit. Okay. So let's open this web page called as OpenAI Tokenizer. Okay. You'll understand what the token is, because token is the default measurement unit. You have to be very, very comfortable with this measurement unit now. All the pricing, all the capabilities, all the inputs to the models, all the outputs from the models, everything is measured in terms of tokens. Let me repeat that last statement. Token is the default measurement unit of the input outputs of all these models, at least the text based models. Okay, the pricing is based on these tokens, both the inputs and the outputs, the context. Okay, so context means how much information it can keep in memory. That is called as context window. Okay, context window means how much information it can keep in the memory. Now, this information could also mean you are making chats with ChatGPT, correct? Back to back, you are chatting with ChatGPT. So all your inputs and the previous outputs are also stored in the memory for some time, correct? So that also goes into the context window ultimately. Okay, that ultimately goes into the context window. Okay, so but before I get back to the context window, let me again open this very first link. What did I type? OpenAI tokenizer. You can do it at your end also. Okay. So this is the link, and this is what I have. Okay. So let me write my name, Prashant. So my name is one word, but the model does not see my name as a single word. My name is seen by the model in form of three tokens. Okay. What are these three tokens? PR, Ash, and Ant. Okay, so if I provide my name to the model, I consume three tokens as the input because I provided my name to the model. Okay, so let's say my name is Prashant. So you can do this. My name is Prashant. Okay, full stop. So essentially, how many words you have? One, two, three, and four. So for English, it is four words. But now you have consumed seven tokens. You have consumed seven tokens. My space is, sorry, space name, space is, space PR, Ash, and that full stop. So total I have consumed seven tokens in this process. Okay. When I provided this information as the input to the model, this information is being provided to the model as an input. Even as an input, I have consumed seven tokens. Now let's say model is providing one paragraph as the output. So this is the paragraph which came as an output from the model. Okay. So let me just replace that. Just imagine this is the output coming from the model. Okay. Now that output contains maybe 15-20 words, but ultimately that is broken down into 34 tokens. So, okay, I am going to be charged seven tokens for input and 34 tokens for output. Fine. Let me go to another page, OpenAI pricing. Check this. Okay. So I'll just take one of these models, okay, just for the sake of discussion. But concept remains the same for Gemini models, Claude models, every other model which is proprietary. Okay. Now this is what exactly I was saying. So this is your GPT-5 for context of the discussion right now. You can see GPT-5 being highlighted here. So for inputs, if I'm giving 1 million input tokens, I would have consumed $1.25 in my credit. So of course, it's a prepaid model, business model. So I will, fund my account with some 30, $40 first. Okay. So while providing inputs to the model in the form of documents, which is going to be a potential context, because my model is going to search for the exact information. This information is present in this document. I don't want to read those 10 pages. So what did I do? I uploaded that to ChatGPT and simply asking a question, where is this information or what is this value? Search and give me a value. Let's say it is regulatory filing of some company. Okay. And what was its revenue in 2024 and how did it change year on year with respect to 2022 and 2023? So that is the question which I have asked to the LLM, and I have given the regulatory filings um, of, let's say, some company, Uber or something, to the ChatGPT. Okay, now ChatGPT will read all the pages, keep everything in its memory. Memory means the context. Okay, so you are consuming the context, number one. Okay, so context consumption is one thing that has nothing to do with the input output tokens. Okay, so context is one thing. So while you are consuming the context, you are not going to be charged. Okay, when you're consuming the context, you will not be charged. You will only be charged for the prompts that you are giving. So whatever prompt I give. So here is the regulatory filing for Uber company for the last 3 years. This is my so and so question. Give me the answer. This is your complete prompt. Let's say this prompt took 50 tokens. So you will be charged for 50 tokens as input at the rate this. And let's say the model gave you 1000 tokens as the output. How much? 1000 tokens, because you have asked for an elaborate comparison between the last 3 years revenue and this and that. Okay, just imagine you have got 1000 tokens in the output. Of course you can restrict. How? That we will see in the labs. You can restrict, but let's assume for now the model has responded in elaborate detail that so and so has been the year on year performance of this so and so company. This has much, this is the amount of sales it has done, this is the balance sheet, debts, and so on, everything it has given, and how these numbers have been changing year on the past 3 years. That complete comparison you have, and that entire output, let's say, consumed 1000 tokens. So this is where the charge would be. So for 1 million token outputs cumulatively, you will be charged as $10. Okay. So these are my for output tokens. So separate billing for input tokens and output tokens. Most of the models will bill you even for the prompts that you are giving, because prompts do contain context. So now comes the tricky part. Okay. So this 50-page document that you have given or 10-page document that you are giving is a part of your input context initially for the first time. Then it will perpetually remain, I mean, in its context until you go or get out of the chat. Okay. So the first time when you uploaded the document also had 100,000 tokens, because, or maybe 1000 tokens, depends on whether it is a 10-page document or it is a 100-page document. Imagine that it is a 10-page document, then in that case it might be a 10,000 tokens. So 10,000 tokens coming from the document also which you have uploaded, 10,000 tokens from there, plus input tokens which was 50, plus output tokens which was 1000. See, everything will be charged to you. Okay, now this will be charged as per the input, and you have this as a separate output. So this is my output, this is my input prompt, and this is the context. So once the context is provided, it will remain in the memory for some time, epipheral memory, if you remember that. And every subsequent prompt will be charged, and every subsequent response coming out from the model will be charged. Okay, at these two rates. So this is the case with all the models. You can go to any of these models, proprietary websites, and get to the pricing. So you can see the Claude pricing, you can see the Gemini pricing, you can see the GPT pricing. Okay, all these models, whether it is text generation, image generation, all these models were pricing scenario. So we'll not get into all the details right now, but at least for the text-based models, the GPT model, this should be clear right now. At least if this is clear, I can move ahead. So token could be a single word or it could be a part of word. That is what the models or it makes sense to the model. So models have not learned to understand the meanings of the entire word. They have learned the meanings of tokens, and they are also giving output in the form of tokens. So tokens is what they have learned, and tokens is what you will get as an output. That's the clear, you know, statement I'm giving here. Okay, so if you thought that models are learning text as words or lines or sentences or paragraphs, answer is clearly no. All that text, lines, paragraphs, book, entire web page is broken down ultimately to tokens. So token is what the model has learned. The meaning of each token, the context of each token is what the model has learned. And so the output of the model is also token by token. So the only thing which looks human is the deep learning architecture, the neural network, and the neurons. That's it. And there is no other similarity, because if we try to imitate everything from the human brain, that is what people were trying to do all these days, and they were not progressing, because machine is a machine, machine is not a right. The moment they thought out of the box, that transformer architecture was created. Because until then, we were talking about CNN and RNNs, which were imitating the human brain and the human thoughts. Please pay attention here. So if you are using ChatGPT from the front end, the web interface, if you are using ChatGPT from the web interface, you have already paid $20 or $23.6 in India, including GST, and there is no additional charge. Okay, but if you're using the same GPT-5 model via API call from the backend, because we don't develop the applications using the front interface, the backend, I mean, will be creating applications which will interact with these models using API calls. API calls to these models. So when you are making API calls to these models, over and above to your subscription that you have already paid, these API calls will also be chargeable. These API calls will also be chargeable. Clear? So if you are uploading it to the ChatGPT interface and getting your answers, fine. But if you want to get the same thing from the backend, I mean, using a Python code, okay, let the Python code upload it to GPT and let the Python code get the response from the GPT. That is where the things are chargeable now. You will be using ultimately the Python code to create the application. You will not use the front end to use the application, correct? So this will be chargeable ultimately. So that is why one has to be cognizant of these right from the start. Okay, perfect. So let's come back to our discussion. So the problem that we were discussing is this simple, that if our enterprise information is not present, not present with the LLM, okay, we can use a web-based search, okay, and give the top results to the LLM, and from there the LLM can search for the exact information and generate the answer. That is option one. But what if our information is never present in the internet altogether? Then it's present in some form of a document. You upload the document using front end or using the back end, either way, whichever is comfortable to you. In that case scenario, again, there are two possibilities. What are the possibilities? If that additional context that you are feeding to the LLM is small, so as it fits in the context window of the model. Okay, I was talking about context window. Let me just show you the context window. Okay, so OpenAI models. If you just look at the OpenAI models, okay, I'll just clear all the drawings. This is again your GPT-5, and you can see the modalities that it can do, speed, reasoning, this and that. Yes, this is the context window. You see, for every model, there will be a context window. So 400,000 context it can keep. Beyond that, it will forget some of the previous information. If you keep dumping more and more, okay, then the previous information will keep getting lost. So if you have a big data, let's say, which exceeds the context window, you still end up with another problem here. 400,000 token is the maximum context window of this particular model. Okay, some other models. So, for example, if you see, this is for GPT-5. Okay, now if you go to slightly older models, okay, maybe this is the open source model of GPT. Okay, this is the open source model, and see the context window. Open source model has got only 131,000 context window token as the context window. Okay, so that is almost one fifth, one fourth. Okay, whatever. So that is the point here. Okay, the only thing is this is free open source, so you can very well use this. Okay, not a problem. But again, back to the same. Yeah. So back to the same discussion. Okay. If it fits within the context window, you are good. Worst case scenario, if you have hundreds and thousands of pages and it doesn't fit in your context window, you are still running down into a problem there. Okay. You can use, there is a concept called as large context models. So there are some models which really have large context. Okay. So extended context or large context models. So some of these models have really large context. For example, 1 million token. There are even DeepSeek models with a 2 million token. 2 million token. Okay. So these are called as large context model. To some extent, you can experiment with large context models if your context that you are providing to the model is huge. Let's say 1,000 pages, 10,000 pages, 10,000 pages, which goes into, let's say, 1 million tokens. Then you cannot use any of the GPT models. Probably you'll have to search for either a Gemini model or a DeepSeek model, or a model which exceeds easily 1 million token, because additional token will be needed to take your prompt. It's not only the information, but your prompt and the previous responses will also have to be saved in the context window, right? So otherwise it doesn't function. So you need a model which exceeds 1 million token, not exactly 1 million token. Okay. So you have to look for a large context model, but question is, does that solve the problem? Okay. So here we run down into two further issues. One is what we call as a needle in a haystack problem, or lost in the middle problem. Any idea? And the other is context window exceeded. So even if, let's say, everything fits in the context window, but still, what is the guarantee that your model will be able to retrieve the exact information present in 1 million tokens? Your 10,000 pages have already consumed 1 million tokens. So from 1 million token, you are literally tasking the model to search for a specific information in 1 million tokens. That is pretty challenging for any model. And there is literally no guarantee unless you have written down a very super sophisticated prompt for reasoning, for thinking, for re-evaluating, for iterating, for multiple techniques it uses, so that it tries to verifies on itself or by itself whether I'm fetching the right information or not. Okay, so that is the point. Even though it fits in the context memory, still the retrieval of the correct information could be pretty challenging. And still, in that case, the model can hallucinate, even though you have provided context, but the retrieval was failure. And so, since the retrieval was a failure, means it couldn't still retrieve the right information, the response generated is still absurd. Okay, so you are still in problem, back to the square one. That is the problem number one. And this is the worst case scenario where you are working with 100 documents, each of 10,000 pages. Now, definitely, your long context model is of no use. Okay, because now you have hundreds of documents and each document contains 10,000 pages. Essentially, each document is going to consume 1 million token. Now you are looking for a specific information which is scattered across 100 documents. For this, my dear, you will use the RAG system. Retrieval Augmented Generation. We have a complete mechanism to handle these kind of scenarios where we will not dump everything into the model context. Okay, we will do some pre-processing of the original documents. We will implement a super sophisticated retrieval mechanism which is out of the models. And once we have retrieved the right information, we'll give that information, we will augment that information to the model for the response generation. So retrieval is done not by the model. See, understand that last part. Retrieval is not done by the model. Model is not searching for the input, the information. That entire searching and retrieval process is external to the model. That is implemented by a sophisticated framework. Of course, when I say framework, it's a Python code. So there is a Python code which will do the searching, it will do the retrieval, and once it has retrieved that this is the actual information which user is looking for, but that information is in a very raw format. I cannot just directly give it to the user. So what do? I give that information to the LLM along with the user's query, that this was the user query and this is the information which is needed to answer the user query. Please generate an answer. Okay, so LLM is only going to generate the answer based on the user query, number one, and the retrieved context. And that is exactly what the RAG solves here. That is what exactly the RAG solves here. RAG again is here, just a quick. So we will implement a detailed search and retrieval mechanism. We will implement, that is a manual process based on some framework. Either we will use LangChain or LlamaIndex. Okay, we will implement a detailed search retrieval mechanism. It has nothing to do with the LLM. Once I have retrieved the correct information from my documents, several hundred thousand documents, whatever that be, that information will be given to the LLM along with the user query to generate the final response. That's exactly what I'm saying. Augment by combining the retrieved information with the user query. That augmented information goes to the LLM for the response generation. This is completely external. This has nothing to do with the LLM. Own choice of LLM later. So here the prompt template that you are going to use will augment this user info along with the user query. And in the user query plus some system message would be there. And that system message is where you will condition the model what kind of response the user is looking for. Okay, that conditioning is done by using a system message. So there is a user message, there is a system message, and there is a context. Three things. The context is retrieved context, not the original context. Original context would be 100,000 million tokens. Doesn't matter. But I have already retrieved the right amount of information. That right amount of information along with the user query and a system message which will condition the model, whatever LLM that I'm going to use. That you have to act as a chatbot, helpful chatbot which answers the user query. This is the context. This is how you have to answer. Everything is formulated in that prompt template. So there is one more step. So you have the raw documents, let's say your PDFs, whatever you call it. Okay, that is basically also stored or indexed and stored. I would say indexed and stored. So the retrieval happens from that stored information. This word is very powerful here, indexed, because I need to identify which page contains what information. So I literally have a page wise information index. So when I'm looking for a particular information, I can instantly figure out, okay, this page from this file or this particular document contains this information. Let's retrieve that page. So that storing is done in something called as a database. You will you will implement a database. So there are multiple things when you are, parsing the raw document, when you are doing that indexing. So again, there are a lot of technical words which will come into picture. I'm just trying to give you a simplified version of it. So let me summarize. So you have set of hundreds of raw documents which do not fit in the context window of the LLM, and you are still asking questions. So what is the solution for that? The model cannot search for hundreds of documents. Okay, that's already exceeding the context window of the LLM. That is the problem that we are solving. It has to be very clear. Okay, what is the problem that RAG is solving? Okay, plus grounding, because I don't want the model to simply generate the answer on its own. So I have to do grounding. I have to somehow figure out the right information. Where is it present? Okay. So yeah, so I have to somehow be able to store all this information in a proper structured manner. And that is what we call as the database. So I'll be storing all the documents in the database from where the retrieval will happen. So retrieval will happen via some elaborate Python code that itself is called as retriever. Okay, so there is some search and retrieval mechanism going to happen. Searching based on cosine similarity, BM25, and number of algorithms are there based on searches. Okay, so what kind of search you want to do? So just imagine that we have done some search, we have retrieved the information. That retrieved information is what you are augmenting to the LLM and saying that okay, this is what the user has asked, this is the context. This is how you have to reply. Please generate that reply. End of the story. The only problem is this still doesn't solve all the problems that is faced by the business. And that is where the fine tuning will come into picture. So I'm just trying to tell you how things evolved. Somehow people, step by step, that reasoning and thought process is important. Because if you don't have this understanding, you will try to implement this or that out of random thoughts, and that is where the problem starts. Okay.
AI's limitations like hallucination, bias, and knowledge cutoff are real challenges. But with the right solutions like RAG, we can overcome them. These techniques are key to making AI more powerful and reliable. So, want to learn more and master these techniques? Definitely join our free masterclass that's coming up on AI and machine learning. So, don't forget to subscribe for more insights and definitely check out this video next.